All right, this is problem 1, narrated by Jim Kendall. So the question reads, John Snow is thinking of buying a castle that costs $600,000. As the head of the local government, he expects to collect $35,000 in taxes after his first year, with an increase of $5,000 each year afterwards as his population grows. He would, however, have to pay the king a flat fee of $3,000 per year in tribute. He plans to retire to a nice summer home eventually, and therefore will sell his castle in 30 years with an expected salvaged value of $128,000. What is the net present value of this endeavor if I equals 7% and all cash inflows are continuous? His alternative choice is to invest in a pirating organization for $300,000 that will pay $65,000 annually for 30 years, also with I equals 7%, should he invest in the pirates or the castle. So for this problem, the main issue we have to deal with is organizing our information. So we start out with an initial investment of $600,000. This is an outflow since we're paying it, and it is at n equals 0. Therefore, when we go on to find the net present worth, it is already in its net present worth form. Next, we have $35,000 a year in taxes that are coming in, with an increase of $5,000 each year afterwards as the population grows. So we start out with $35,000. If we were to write like a cash inflows and outflows table, we'd start out with $35,000. Second year, we'd have $40,000. The third year, we'd have $45,000, and so on for 30 years. So we can see that this is a gradient series, which is why it is increasing linearly for 30 years. Obviously, these are not to scale, but I did my best. So afterwards, we now have taxes of $3,000 per year that we have to pay. And this is just the same amount every year. It's an equal payment series of $3,000 all the way through year 30. Then at the end, on n equals 30, we have our salvaged value of $128,000, and that is at year 30. And we need to find the net present worth of this whole problem. Then after that, we have the second choice, which is the pirate problem, which this project starts out with $300,000 as an investment. And this is, we are paying this, so it is clearly an outflow. It's down. And this is at n equals 0. And each sequential year, we are getting $65,000 all the way until n equals 30. This is an equal payment series, since the same amount is coming in every year. So we just need to find the net present worth of this. Looking ahead to this problem, it seems like this will be much easier to solve than this, because we have a lot more going on over here. So it is very important to organize your information and really visualize what you're doing, if not just to write it down, because that's really what you need to do to solve these problems. So with that said, let's move on to solving the net present worth of buying the castle. So now that we have our graph, we need to see what we need to do. So we have this gradient series, but since it doesn't end at 0, we need to find this equal payment series and add it on to a gradient series that would equal 0 if the equal payment series wasn't there. But first off, let's deal with the initial investment. Our initial investment is $600,000, and we are trying to find the net present worth. Therefore, it is just $600,000. This is an outflow, so it is negative. Next, we'll deal with our equal payment series, which is this linear gradient series minus the linear gradient part, making it an equal payment series of $35,000 for 30 years at 7%. And it is an inflow, so it is positive. So we have 35,000 PA 7% for 30 years. Next, we'll deal with the gradient. So with the gradient problem, we are increasing by $5,000 each year. So our gradient is $5,000. This is for 30 years at 7%, and it is an inflow as well. So we have $5,000 PG, 7% for 30 years, and it is positive. Next, we have our taxes that we are paying. These are outflows, and as you can see, they are continuous because they are $3,000 each year. They are not increasing or decreasing for 30 years. From this, we can see that this will be another equal payment series, and it is an outflow, so it should be negative. We have negative 3,000 PA 7% for 30 years. Lastly, we have our salvage value of the castle at the end of the 30 years. This will just be a simple PFIN problem where we have $128,000, finding the present value 30 years before. And it is an inflow, so it is positive. So we have 128,000 PF 7% after 30 years. Now we need to go ahead and calculate these values. Negative 600,000 stays the same. It's an easy one. And then after that, we have an inflow of $35,000 equal payment series. And this we will calculate to be inflow of $434,316.44. After that, we have a gradient series of $5,000, and this comes to be $604,859.12. I think it's kind of interesting that at the end of the 30 years, the amount that we end up getting from those $5,000 increases ends up being almost 50% more than the original $35,000 per year that we were getting anyways. Next, we are paying the taxes of $3,000 a year for 30 years. This comes to be negative $37,227.12. And finally, the present value of our salvage of the castle of $128,000, 30 years before our salvage, that is valued at $16,814.19. These are also interesting to me because when you think about it, $128,000 30 years from now doesn't come to be that much in the long run. Now, finally, we add these all together, our inflows and outflows, and we get a total value, present worth, of $418,763.43. Next, we deal with the pirate problem. This one is much simpler than the other problem, considering it's all just going on the same for 30 years. We have our original investment of $300,000, and that will not change, and it is already in its net present value form, and it is an outflow, therefore making it negative. So we have negative $300,000, and then we are getting $65,000 annually for 30 years. Therefore, this is a simple equal payment series coming in, which is an inflow, therefore it is positive for 30 years, $65,000 PA 7% for 30 years. Next, we will calculate these values, negative 300,000, still just negative 300,000, and we're adding on $65,000 and equal payment series of 7% for 30 years, which comes to be $806,587.68. And this is an inflow, so therefore it is positive. We add together these two values, and we get a total present value of $506,000. $506,587.68. Next, we are asked to compare the two to see which is the more optimal solution. Now we see that the castle is only $418,000, whereas the pirates' investment is $506,000. Therefore, it is pretty clear that we should invest with the pirates. I find these problems interesting because there's so much going on, yet you need to keep it organized, and I feel like that's a big problem for a lot of people. With problems like this, you really just have to sit down, look at it, take it piece by piece, and when it all comes together, it really isn't that hard. Especially with this, I mean, you just have numbers flying all over the place with this castle. Inflows and outflows, especially with the taxes, it can be confusing because there are taxes coming in, taxes coming out. But in the end, they're just a few series that you have to deal with, and when you come to the end, you find your answer. And it is also interesting that though you are investing a lot less with the pirate problem, I really would have expected this to go in the favor of the castle, just because this increase of $5,000 per year. I mean, what would that be? After 6 years, you'd be making as much annually as the pirates, and then you still have another 24 years after that the castle will be making more money than the pirates. Except, I mean, I guess with this $3,000 per year that you're paying, we'll decrease it. I just when I visualized it, I really would have expected that you'd be paying, that you'd be getting more money with the castle problem. But when you calculate it out, well, it's a lot more with the pirates. So I hope you enjoyed this problem, and problems are good practice for when you have a lot of information and you need to keep it organized. So I hope this was helpful. It was definitely helpful to me.